जॉइन हुआ ना मैं। Some of our ongoing advances. So, as I have been given a topic, the current advances in applied physics. This is a very broad topic area, and I know many speakers have already delivered their lectures. I covered a small portion, and that portion is also motivated by mobile, because they are using mobile. In mobile, this is a very electrical one. A different type of software, camera, and audio system. If you see, we can divide this thing into two parts from my point of view. One is called the optics, where you are basically taking camera or recording or collecting photographs, and other is the audio system. So, in this lecture, I am going to give some flavor of development of some tunable laser-based spectroscopy and imaging techniques for analysis. And this analysis is related to the high energy molecules or exclusive. So I am basically associated with the Advanced Center of Research in High Energy Materials. This is a center. It's a brainchild of Bharat Kalam sir. So he wanted that academia to work with for the defense people. And this center is dedicated for analysis of different type of high energy molecules which act as a fuel for the rocket. So our fuel is now also used for atomic design. And we have a group of 5 physicists. They are basically investigating the high energy molecules to understand their molecular dynamics. And in order to that, we use laser as a tool. So this is a brief what is called thing. Yeah. So if you come to the camera, Yeah. So we are the neighbor. Become your neighbor. How they will find. But we will find some sort of program on one lake is also there. Campus. Well, so when we are talking about development in the field of spectroscopy or acoustics, I will discuss, will show the small spectrum, and then spectrum is very important. Moving from left to right, frequency from 10 to power 7 to 8, which is known as waves. Then you are coming in a domain of 9 to 10, the microwave. Then 10 to 12, this is a small range. This is also known as a terahertz range. Why it is important I will my talk. And then we are again entering in an optic zone. So this is called your infrared 10 to power 10. Then visual light, then ultraviolet, and the X-ray. So this is the full spectra. So I am confining myself from 10 to power 10 to power 14 or 15. Selected for making different type of devices. So one thing more, because yes, people are complex. So 0.1 to 10 terahertz is equal to 10 to 300 centimeter. For physics point of view, 1 terahertz is equal to 300 micron. That is the best and the definition. So if any radiation order of 300 micron can be known as a terahertz radiation. Again, yeah. Once again, so this classification again becomes very important. So I shown the electrometric. So this is again further divided into two parts. So left hand side portion, which is started from radio wave to microwave, is known as the electronics, electromagnetic radiation, electronic part. And when you are entering from here to here, this is known as a photonics. So this region is a bridging region, the terahertz, which basically combines both electronics and the photonics. So what is the advantage? The law of all optics, quantum optics, is applicable. But once you move to the left hand side, only electromagnetic radiation, Maxwell equation, pure Maxwell equation, that is applicable. So that is the difference. Once you are entering in this domain, it means you can do a lot of optics. Well, so it's the reason, and this technique is highly useful for especially for the non-destructive texting. It is also very useful for defense. Then the food technology, communication, I will show some interesting applications because we Indians are basically, and especially Hyderabad, they are very much attraction to wet water. Water is not common nowadays. And because after 2030, the underground water is going to die out, and there will be a building construction. So we have to adopt a mechanism which can prevent us to save our life, right? So these are the things. Yeah. So in my talk, I divided two parts. One is called objectives. I will tell you what are the objectives, and then introduction of the technology, and then different type of optical photography, optical and the optical part I will emphasize on the art, and photography I will emphasize on acoustic. It is a combination of optical. And then applications, and then I will come to. So once again, I will give the field level, I will knowledge. So terahertz has certain advantage. One, it has a very high absorption in a water. The absorption coefficient 250, which is transmitted to the water, it will be totally absorbed. So that is the one drawback you can say, but advantage also. Then from metal, it has very high reflectivity, around 99.5%. So all metals like aluminum, copper, they are very good reflectivity. Then plastic or any leather, rubber, You see the absorption coefficient order of 0.5. Spectroscopy is using materials are transfer. And light and photograph pass without any hurdle or hindrance. And then especially for the semiconductor, what is happening, there are a lot of technology and we must know that properties, whether it's or not, true or not. So what are the devices you know? So terahertz is the best. You can get it. And if you see the refractive index of the plastic, it's 1.5. What is the refractive index of the glass in optical? 1.5. It means it is constant. Very, very simple value. We use like that material, but it is not overall. But when you object the material to the stellar domain, you find either result, what is that? Yeah. Either result, some person is carrying some instrument, knife, gun. If you do the scanning, you can identify what it is. Similarly, some sort of a, robots are carrying attack inside the room, how many people are there. There's a device, you can identify how many number of people inside the room. The most important part is the water. Water dynamics are the law of stress, very important, and that is of the plant and the field. Both things are involved. So, study this thing, you can identify the requirement of the water and dryness of the dryness condition, and you can also increase the yield of the on the particular. So, using terahertz, and very soon you find in agriculture that water is not that very for very commodity product. And then medical, of course, cancer. You can see water and this is the protein molecule. This can be identified. There are these are some of the what is the other common things. We are basically involved here. So this is a task. Yeah. So these are the signatures. So reason is that many things are possible. We are able to identify the spectroscopy. Even function will be there. So as a result, even the idea is also. So it's very difficult. But when you come in the derived domain, their signatures are totally different. Like and especially for terahertz, signature at 0.82 or the other. So definitely it is a cross verification of a sample whether particular type of are hidden in the shoe or bag or where anywhere so that it will be. So this is a device. Many people using other places. That's all my doing all these things. So the thing, this is so the thing how get over. What get doing I'm telling you. How we learn that I can go to the senses of. This is another popular. This is not my work. Okay? It's stolen from either the network or web. And to give the information, I will do my own. So this is not the micro. You can see the picture is there. Somebody is there. Yeah. So let's come to the actual business. That is called the output. And therefore, the so we are 175. Very old, right? But now we want that overheating and everywhere we compare that technology should be like a mobile one. So this was done in 1880. And what we did, we have taken a sunlight. As a reflector, very classic experimental. and I will tell you what is the lectures segment here. So this we have taken a sunlight. Sunlight was, it was expected focus to alarm cell, alarm means literally what is cell, and then it was sent to the mouth. Then we measured first some sort of a speaker type of thing, and then the sound was redirected to the one parabolic reflector, and from there he took his invented earphone, what we are using now, right? And this earphone was recording what? The sound which is basically guided by us. So there was a first demonstration in 1800 Albert Campbell, and that was the discovery. And he has then mentioned this thing, and the device is known as a photophone. Light. So the first voice telephone message was transmitted by means of light for some 2000 in Washington DC. And Bell delivered a lecture in America. And what he mentioned here, I heard a articulate speech by sunlight. I heard a ray of sun laugh and cross sunlight. I have been able to hear the shadow, and I have seen perceived by ears of passes of clouds and sunlight. It means you are very much excited, and he said in his statement that the sunlight whose part making an audible sound. So that is the first development. Right that time, computers were quantum optical was came, after that, everything came into the picture. After what it was 1920, it became very much concrete. That was right? So, what is photoacoustic? Let me tell you, because it is not a very masterpiece real diagnostic. So, it is basically an absorption light is absorption. So, it is basically a technique which translates optical energy into an electrical. So, sound is what? It is medium. Without medium, it cannot move. But for light, you don't need it. Then, when the sample is illuminated by the light of specific wavelength, correspond to the absorption band, it is responsible for the excitation of the sound. If the light is passing through the medium, the molecule is and because of that, what is end up kinetic energy is the pressure. Because the molecules are coming back to the normal. There is a type of process. One is ready to, other one is non-ready. Ready to process, you get a photon. You can detect with the help of any photonic detector. But there is not ready to process. Mechanical, sound level, pressure level. For that, you need some sort of an answer. Okay. So depending on the sample, the detector measures the kinetic. Okay. So this is another part of simplification. What I told of my statement. There is a radiation, absorption is taking place. Atom and molecules are moving from one to the upper energy state, getting excited, coming back, vibration, rotation, which is appearing in the form of this heat wave basically when comes in the medium, they expand, move in the medium, and then it can be detected with the help of this is converted to the acoustic wave, and this acoustic wave can be detected with the help of micro. So this is all acoustic. And when we are doing this thing, what we are doing before that, so this can be applicable for any type of medium, solid, liquid, or gas. But only thing is that why system is required? System basically protect when the sample is too or three ways. First, external noise, because they are speaking sound. Too many people speak, we cannot hear. So similarly, the noise of the molecule has to be For that, we have to have a special type of chamber where only this noise or voice should be there. Second, external noise should not enter there. Second thing, the voice is very so we need and that amplifier basically should amplify what? Acoustic. Electrical signal is the second part of the. So acoustic signal can itself be amplified inside them. You can ask how. Best example, flute. The flute player, if you see it, Hari Prasad Chaudhary, any, I mean, our Bismillah Naik, you see, I have seen this program, all the, so they have different kinds of, flute or canine, what you can say, different, small to big. So that basically give a different type of notes. And those notes basically help you to amplify the sound according to the vertical raga. So the similar phenomena is taking place. This is the sound, kind of sound. So this has to be done right instead of a spectroscopy. And you can record different type of signature. I am interested to find out NO2. Why NO2 is important? I will tell you the reason. Yeah. So this is another representation of the same mechanism, excitation, then heat wave, acoustic wave generated. So this heat wave is radiated from the molecule. This is the only part. So this was the first and the second development. So here what is happening? We have the light source. Your laser didn't come in the power. So people were using an ordinary light source. This light source was basically this was modulation. So once you modulate the light, they are giving two types of help. One, the light is giving, signal is generated, it is deactivated, by that time, light is dropped for a moment. As a result, signal will be amplified. Right? Then the noise is also amplified. But noise and signal, they are different. Noise is appearing at a regular interval. But noise has no position, it can appear anywhere. So in order to increase signal to noise, this modulation that is done. Then you use a filter. Then you can make a cell. So you can select a particular wavelength. And this cell you can house among the microphone. This microphone basically collects the sound signal. And then sound signal can be amplified like loud speaker. Right? So now what we are doing is connecting the help of computer. You can record the signature of generated signal in terms of time as well as speed. Well, so now I will tell you the very latest paper. It is Mustafa Gowda and so this is old technology what I told. Now this came to the new surface wave. Also they are telling now. Now reducing in the society. The law wave is very, very important role. So this why I told a now wave. So I will tell you. So basically they made some sort of a structure. This structure, madam, am I right or wrong? Yes. So now terminology also used. We have not all this thing. It is right? So this is basically a wave, and for that, this is also. So you see the big chamber that is reduced to now miniaturized system where lithography is used, and this material is a piezoelectric material where you can make a structure like this, and that. And what is happening? This is kind of right here. This piezoelectric material may be quartz, gallium arsenide, so many things you can make. So one side it is basically exciting the what is called this wave, surface wave. Here not a surface acoustic wave, and the other side is basically. So this is called the design of the sphere or the law wave, how it is moving from. The law wave is a surface wave with a horizontal motion that propagates clear mode wave supported on a semi-infinite substrate with a waveguide layer and exhibits a shear acoustic speed lower than the rate of the solution. So So this is basically moving in the substrate order of 1 to 2 lambda. And moving. The area where this wave can move and where it can carry the information of a different type of material present, and you can record their characteristic signal. So this is how technology as we are talking about advancement of it started with the cell, and cell is now using for recording of different type of biomolecules. So how this is you might have seen somewhere people use the surface carbon resonance sensors, where electric field is produced and the molecule on the surface is arrested by that field, and it uses image of here. The same thing is done by the acoustic. So acoustic wave basically helping you to identify different type of virus, cancer cells, or this thing. So this work as a receptor, and the whole thing is like that, input and output. The surface acoustic wave or low wave can help you to identify the material, and this is the signature thing. You can see what type of signal you can get. So this is the signal you can get it, right? So this is a very latest development now what we are doing. So you see a photoacoustic. This is a very important area because now it is coming into the imaging. So every year the papers are now keep on increasing. So this is recorded up to 2019. So every year people are published. And another thing is staging, and there is actually $1 billion. So very big industry which has potential for all type of imaging photographs. Okay. So when we are talking about our design, mathematics is very important. These are mathematicians here. So sir, we are using here a in-movement linear pressure second order. If you make it 0, d square now d square by 3 by d square minus 6. If you make it 0, then homogeneous pressure. But homogeneous pressure is not to act as a transfer or a reduction. What is happening is when signal is produced, you have to supply something, and that is done with the help of a laser. So laser basically gives the energy, and it basically forms some sort of a harmonic oscillator, force harmonic oscillator, where you can overcome the dancing mode. So everything sound is produced, decaying in the second. After a certain period of time, again the laser beam is falling, again it is produced, and the laser in the cavity will form a standing effect. So we get very strong thermal acoustic signal with inside the cavity. So that's why this equation is very important. And when you are dealing with this thing, we use a Bessel. Because Bessel functions are used to locate the different mode positions of the cavity. That depends on the size of the cavity. So you will solve this equation, I spent 3 years to solve. I tried hard. Mathematicians do not understand physics, and many physicists did not understand mathematics. And I was taking my head, so I spent 3 years to solve. But I solved. I made a very good mathematician, and I solved. And after solving that, I will tell you what we have done. So then you can find the amplitude, what are the amplitude, and then you can detect the frequency of the cavity. So this thing can be done as a cube. So this is the first paper by Milkus and Peter Hess, and the second by my first student, very bright, right? So he was working with me, and he was very good. He was running spectroscopy with me, and I given him the task behind. You solve this better and make a program. And he was very keen. So we solved, because I solved 2.5 years. Finally, I got a solution. I wanted to make it. Zero mode I wanted to find. And zero mode when we got, I told now you write the program and let us decide by changing, selecting a cavity, how this mode will be attacked. Yeah. So this is the mode. This is the cavity, and these are the modes. You can see. So no antinode, nodes, antinode. So by this, you can find a different type of mode excited in the cavity. Your laser light. So when the laser is passing, the medium is filled with the gas, what is happening? You get maximum and like a thing in moving, you will find maximum, similar type of things. So we started doing this thing and we identified three types of modes. One is the longitudinal, which is convex. Then the radial. This is radial. Beam is passing, so across the beam, modes are produced, and the most popular transport. That's called radial mode. So this mode is produced around the wall of the cell. So three modes. Now question is, three modes are produced. Yes. And resultant can be constructed or destructive in the net. There are certain points in the cavity where all the modes can be, and you can get a very strong signal. That was the problem. And we tried to solve, and we found that there are certain positions where this mode can interfere and very good and very strong. So we solved it, and these are our systems. You can see different size of our fluid, different type of cells. You can see this is the biggest one, and then the smallest is also there. This is the smallest one. So this, I'm in Hyderabad, psychology class, very good there. Design I was doing, characters and we are doing design. CNC machines are available, and you can make. But question is not making, question is observation, whether it is using or not, that is the thing. So, reason was, we are using 532, we have a laser, we have new also, not much activity, 532 was available, and only there was expected that was NO. NO is very expensive. One Coca-Cola bottle costs 1.5 imported one. There is money and that takes the time. And second thing there is no other yes we know. I know because I was teaching masters, so I only refer can be. So we want to characterize our sample. Then I said no problem, we'll let NO. I purchased one bottle that took another 6 months. But before that, chemical reactions we did and we subject to the cell, and that helps us to generate photoacoustic signal. This signal is transferred to the preamplifier. Preamplifier is connected to the 200 megahertz oscilloscope. Then we design our own what is called to the signal. Okay. So this is a development. Yeah. So this is the experimental setup. The first experimental setup is the big cell IC. So green light you are seeing, it is a laser. This is a vacuum pump, fitting arrangement. This is my oscilloscope, and the bottom we have a computer. So all things are there in each step. When you come, you can see how system is working. So we started and we got success that we can do that. Why? Question is why we want to do. Reason is that if you say explosive, you have NO2. And there is a part of them that NO2 is. And this NO2 is and we have the source. So earlier my student was not agreeing with that. The molecule it will not really isolate. And ultimately we use that what I was. So what we done, we have done. Started heating with the one. Then we vapor us sent to the cell with the control cell. First it was then 100 milliwatt up to 760 milliwatt. By that they are saying. So what the NO2 is coming and concentration is more, there will be more. That is the proof that it is working. So this is the first design we made and we got a success. This is the design. Then we did for the solid. Here the solid cell is designed. So this is popular design. We will slightly modify it. I will show the design. And then this is the third with the there are most complicated. So Puna is was now and time they want to. So question is NO2 is produced or not? That is the question. And this was the argument. Nobody knows whether it can be done with a microphone or not. So we have seen CDDT thermo differential thermograph. So you can find two types of information. One, the phase change, and then decompose. So once the material is changing phase, you will find small things that is coming and getting like that. And then you see the entire material is basically decomposed. So why it is happening? Nobody knows. Me and my students try to find out why it is happening. So then we decide, okay, if it is coming, so in our system also it is happening. Because it is speaking something, but nobody knows why it is coming. We wanted to know whether it is right or not. So we did our experiment and we got a very good success. So we are the first in the world to identify that MTN1, this is a molecule. That this is basically releasing NO2, and then we completed and this paper was accepted. And these are the noise. So everything people ask what is the order of noise. So it is 10 to the minus 6 to 7 volts. So millivolts order of noise. But signal distance is our, and then you can find how strongly and better way we find. And after that we never. So our design was there because I also identified second, fourth. So all the even number of modes were excited, and you see the mode 1, 2, 3, 4, second. Okay. So well-defined cavities which are calculated and measured and designed, and you can excite your mode. So before when I come into the field in India, I keep on asking questions. Somebody else is going to decide. I developed with the microphone signal. But no, I know why. What is the level? What is the order? What is the level? Then also I think one is in Jamia Millia. I met them in a conference. But question is what I wanted to know. I didn't get one. And for that answer, best of that answer, I sold. I got my first PhD project, and after coming to Hyderabad University, I sold it. So that is the importance of when you are meeting with the right people in the right. When I go in the right competitive office, right? And there you are able to solve the problem. Okay? So this is a NO2 for RDS and DNT. And there is another important paper when dissociate, a different type of gases are also being released. And this is the root of dissociation. This is the first paper by Chaudhary, and Chaudhary in 2005. And they used and Gaussian. And they found the root of RDF with release NO2. SCM. So once again, correct? So there is no dispute. Undisputed that we do. If you heat it under controlled condition, NO2 will be produced. But there are many more cases like HCl, N2O. So this we have verified, HNO2, this we have verified. But it took another, 8 years to modify the system. But of course, when you know the target, you can do it. So this is another landmark work we have done, and that is basically related to the RDX, citric acid, and another 2 molecules, and we compare. So these are the most of the activity. And you can see when we are increasing the temperature, the distance of the signal is changing. So this again we got, and this is basically a model for because when you take a food, so S is very important. If the S is less than O is good for you. So sometimes because there is first type of 4 particles. Bukhar is very good. उसमें लाभ नहीं देती. Because this one has more S, that is a bad code. That is also not good for the. Similarly, for explosive, if there is a residual, then the entire explosive is converted into energy. That will be extra thrust to the missile, and it can also increase the payload. So whatever warhead you want to carry, that you can also increase. So that is basically the mechanism that you can test in the laboratory, and our system is basically demonstrated which material is heavy. Because CDPT is giving me what is the residual amount. Our system is telling how NO2 to do. If you mix all the things, what is called the protocol can help you to identify this explosive can be the best for right. So again, you can see the spectrum of TNT, TL20, TNT. So actually, when I joined, I was the only person. Then 5 minutes. Okay, I will move fast. So these are another, samples with the 266, and we recorded all this spectra. Then this is another, I'm going fast, but I'm showing the results. So this is for TNT, and this thing we use what is called Raman, what is called carbon to find out the signatures. Okay. So all right, we compare this thing. So we designed a multi-pass optics. And we trained in mathematics due to my connection. So I can solve some questions. So I designed this thing very expensive. Russian company has made a real problem. So I'm using a photo. So this is a QCL laser where alpha one was carried out here. So we use this laser. It's expensive. I purchased and then we converted it more. So this is a cell we designed. It's special cell. It's a Helmholtz cell, and Q factor is very, very high. So what is happening? We can see the Q factor of the cavity. I also the design. This is the design. And these are the experimental measurements with the UV. But there are some cells with a different wavelength. Yeah, we see the Q value. So we keep on increasing, right? Why? So this is the experimental setup. So you will see for TNT, the signal is increasing. How much is single now? It is 40,000. We started from millivolts. Signal is 40,000. Means we are heading towards the perfect 20,000. So we have now designed this system, and you can see we can also improve the quality of water pattern for this system is basically going to for detection of NO2, H3, and we got success to measure from this NO2 and this thing HCl, HNO2, etc. From the export. Yeah, so this is another. So I will just show you the Terra system. This is a system what we designed in our laboratory. Again, so every time we are ready, ultimately we solve it. We design and then we record it. But this is a new system. But just the company got very much system of my price, our price. I think not their price. And I purchased, I converted into imaging system to see how the image is. This is a system. You take time domain and so this is the you can see the data in the 0.5. Then point. Yeah, blade. So blade basically inside a envelope. Cannot see, but when you take image, hidden image of the blade can be seen. But blade 1.5 and 2, that was the interface of the cellulose of the envelope. So this is the system. We got another second part. Big system. We almost have 50 like 2 years we work again problem and we design. So at a time one you can record 1, 2, 3, 4, 5 images. Okay. So this is the image you can see of a key. There are better image you can see that 0.1, 0.2. So we keep on modifying the computer program to record your spectrum or images at different frequencies. Step, not step, for a leak. 1 day, 2 day, 3 day, 4 day, 5 day. You can see how the water is drying out. The leak is becoming reddish, and then it quickly becomes. It means the water is totally lost. So this dynamics is helping one group is there. We working on millet. So now we are identifying the quality of millet, seeing the feed and seeing the deep water. So activity is also going on. Yeah, this is the actual business of explosive. You can see These are the type ISO. This is just like RDS. And this is a, alert in Capron, the ink, but you see the terrain. Therefore, appearance is highly type. This is another paper for Prof, different type of drugs. Hospital हमारे हॉस्पिटल में भी यही होता है, तो इसलिए मैंने इसका फोकस किया अभी पब्लिश दैट इज आल्सो इम्पोर्टेंट. ये मिक्सचर है फाइल के अंदर, यू कैन सी सॉल्ट, ग्लूकोज, शुगर. So when you have a tool, you can do whatever you want. You can still. So this is a spectroscopy. This is basically special because the metals and other things are there. They get rather than some other like level. So that atmosphere affects their quality. So we are now studying, and we found that with respect to temperature, how the quality of the fire. Study very new study. Very new liquid image. Volatile material every point. We recorded very much finding of skill. So this is a group for terahertz. So Navi is a person, key person who is working with me. They are largest spectroscopy. Monthly working on manpower on semiconductor material. Mark was done by MSc. He knows everything, and now he joined Pune. So you are with me, and there is another group, the group also. So we demonstrated design and aspects of all these things. Then I have one. So these are the this is 5 awards, several awards. First student award, Jawaharlal Nehru Fellowship, this thing becoming in his country. So he did a lot of progress. Rampage is now in hospital. He got number of awards also. He got a patent on this thing. Model again got a similar thing of thing, and again he got a best teacher award in that. And Royal Society of London. You are invited to last by Prof. So, he is now in China. Arjun is doing very good. He also got a couple of awards. He is going to submit. He is involved in this thing and got a patent. Technology, this is my old group, so this is fine. Thank you very much. Yeah.
Thank you, sir, for a lovely talk. I had one question. The security detectors which we are using now, are they terahertz?
Yeah, terahertz, yes.
They are terahertz. What is being used?
For imaging purpose, what they
accuracy, I would expect like as we increase the power, the emission.
Yeah,
but it is
right. So as frequency 1.5 frequency increase and energy increase, right? But reason is that other materials are also having their fingerprint. So 0.5 to 1, maybe the paper is also having. So that band is also coming with the band of this. So it is also interface. As a result, what is happening? Because of this destructive interference, the image gets distorted. That is the reason. So that is real challenge. If you think a wavelength लेकर के आप identify, no, you have to have a system. उसमें पहले मालूम करो कि इनको आता है कि नहीं.
very good for better.
Exclusively भी आता है. हाँ, we can tune now. यार वो प्रोग्राम है, तो ये तो आपको demonstration में दिखाया. But now we know कि भाई ये चीज इसमें है. We can feed like the space. Yes. And then you can.
Sir, have you designed any system? Yes. Another case and.
NOP is also there. Positive in advance. It is just like plastic. ये बच्चों को जो प्रॉब्लम है ना हैदराबाद में रेस्पिरेटरी, उसका मेन प्रॉब्लम NO2 और सीमेंट. So
let's thank Professor Chaudhary for his lovely talk.
Thank you.
important to have a connection between physics and mathematics. If we can add that. And so I would request Professor Ranganathan sir to please present him with a short to keep the connection with mathematics. Yes. Yes, I request Salim Paja sir to the plug and thank you very much, sir. Thank you so much. Yeah, thank you, sir. And now I request my colleague, Senior Fatima, to propose the vote of thanks. No.
On behalf of Physics Section School of Sciences, Manu, I thank our speaker, Professor A.K. Chaudhary, for sharing his wisdom with us today. It's always a delight to hear him. Thank you, sir, for making our symposium memorable and more impactful. Thank you so much.
So we have 10 minutes break and then we continue. Thank you.